All right, my name is Eric Green, and I'm here with Wintellect, and we're going to be talking about GraphQL and Relay today. GraphQL and Relay are two very awesome, very cool, cutting-edge technologies that make building web applications when you're working with very large, complex, multi-dimensional data sets, makes building those types of applications a lot easier. It makes it a lot easier to actually keep that data in sync with your UI. So we're going to go through and take a look at that here over the next hour or so. So what we're going to do is I'm going to walk us through some slides, kind of talk about some of the concepts and ideas behind GraphQL. Then we're going to take a look at some GraphQL code and actually run some queries and kind of get an idea for how it works. And then we're going to take a look at a few more slides and then talk about Relay. GraphQL and Relay are really kind of two separate but related technologies. GraphQL can kind of stand on its own, whereas Relay actually has a requirement that you use a GraphQL server. So we'll take a look at both of them a little bit independent of each other. We're also recording the session, so later on you can go back and actually download the recording, and you can go back and watch the session again and listen to all the questions and answers and stuff like that. Also, the PowerPoint slide deck here will be placed in the GitHub repository where I have all the code. So at the end of the webinar, I'll give you the GitHub link, and you can actually go and download the source code and play around with it yourself to better understand how things are actually working. Okay, so let's go ahead and get things kicked off with talking about what is GraphQL. So GraphQL is really a replacement interface for traditional REST services. When most developers, or at least a lot of developers, think about REST services, they kind of think about the whole server implementation. Not only do they think about the HTTP part of it, where you specify the verb and you specify your URL and maybe a request body, but they also think about the database access, they think about the business logic. And so if you were to talk to the average developer and they told you, hey, I'm a REST service developer, they really mean that whole big stack of technologies, not just the HTTP part, but everything all the way back to the database. And so when I say GraphQL is a replacement, I don't mean that GraphQL is a replacement for all of that. What I'm talking about is it's a replacement for the actual HTTP verb URL combination aspect of REST services. So when we think about REST services, we think of things like, for example, a GET request, and that can retrieve a collection of resources, or we do a GET request with an ID value, and that gives us back a particular resource. That's the part that GraphQL is going to serve as the replacement of. It's going to replace that actual interface that we think of when we work with REST services. Now, GraphQL and REST services, at the end of the day, basically both try to accomplish the same goal. And the goal is to provide us some type of easy-to-use, convenient interface for either retrieving data or for making data modifications. Now, REST services accomplish this by providing us an HTTP verb combined with some type of URI. So, for example, if we have a collection URI, a URI that doesn't specifically address one particular resource, we have that collection URI and we tie that together with a GET request, that returns us back all of the resources for that particular request. If we actually have an element URI where we specify the ID value, then that same verb returns back a single resource. If we were to take the collection URI and combine it with a post request or the post verb, that typically means to do an insert into the collection. Or if we do a put request with an element URI, that means to replace that particular resource. Anyways, when we think of REST services, we think in terms of these verbs and these collection or element URIs. And the nice thing about REST services is it makes it very easy to actually be able to make these kinds of requests. Unlike doing things with SOAP, which is a very complex standard with a ton of XML, or even doing things like a binary data connection and actually sending packets back and forth, working with REST services makes things a lot easier for the average developer to be able to make requests against some type of remote data source. And because it uses HTTP, it makes it really easy to do inside of your actual web application. And so because of that, REST services have become extremely popular and are a mainstay within the actual web applications that we build today. Now, while these REST services are great and they solved a lot of problems many years ago, they also come with some of their own problems. One of the things that kind of hurts REST services is that there's no official standard. REST services are really based upon a grad school paper that was written long ago. And as they're implemented, there's no official standard by which they have to be implemented according to. Instead, it's more of a convention-based type of thing. And if you've ever worked with multiple organizations before, you quickly realize that what one organization thinks of as a REST service is a little bit different than what another organization thinks of. For example, take the put verb and take an element URI. Some organizations implement that as a replace. Other organizations implement that as an update. Organizations that want to do an update instead of a replace will sometimes use the patch verb. Okay? The point is that there is no actual standard. And so because of that, REST services, in terms of how they're implemented, can kind of vary from organization to organization, which can be problematic if you want to create library code or frameworks that kind of transcend a particular organization. The next problem with REST services is that they have a tendency to deliver very static data structures. What do I mean by that? Most people, most developers, when they implement REST services, let's say you're going to have a REST service of books, and you want to get back a collection of books. If you make that GET request against the REST service and say, give me back all of the books, you literally get all of the book data. Most REST service implementations don't have some type of specialized query language where you can say, only give me the titles or only give me the descriptions. You actually just get all of the book data, whether you want all of the book data or not. Now, if a developer wants to implement some type of functionality into their REST service to allow you to determine which fields you want, you can certainly do that, but it's definitely not something that's standardized. Another problem you run into with REST services is that a lot of data today doesn't really fit that two-dimensional perspective very well. When people originally created REST services, they kind of thought of their data as like a big table, two-dimensional. You have rows and columns. But in today's data sets, you want to think of it more in multi-dimensional ways. We really have a real graph of data. And so when you pull back, for example, book data, do you want to pull back the author data as well? And if you code your REST service, do you automatically include the author data? Do you choose not to include the author data? Do you have to wire up a special customized option for the client of the REST service to tell you how much data to actually send back? So when you start looking at REST services from that perspective, you start to realize that there are some limitations there and some inherent problems you can run into when actually trying to build really large applications with really large complex data sets. Now, since REST services have become popular, and I don't remember exactly when they became popular, 15 years ago, 20, 10, something like that. In the past 10 to 20 years, that's when they became really popular, especially when people started doing AJAX calls from web applications. But a lot has changed in that time period. We've gone from these two-dimensional data sets to these multi-dimensional data sets. And basically what we need to solve this problem is a query language that allows us to specify what we want and then has the ability to deliver back to us dynamic result structures that actually reflect what we queried for. Almost like SQL itself, where you can specify I want these columns and then I want to relate it to these other pieces of data and then return that back to me. But instead of that SQL being limited to just being on the server side, actually making something like SQL be available to us on the client side. And that is the problem that GraphQL is going to solve for us. GraphQL is going to give us this interface that's going to allow us to have a flexible way of actually interacting with our data. Now, the creators of GraphQL is Facebook. And as you can imagine, anybody who has a Facebook page, if you go to your Facebook page, there's a tremendous amount of information on your Facebook page. You've got everything from information about your profile to status updates, to information for likes and other things like that. You've got ads that are on the page. You could have messages that are being sent to you. Any number of things that's actually captured on that one page. So as you imagine a Facebook page, you certainly wouldn't think of a single table of data that represents everything. Instead, you'd think of a very large, complex graph. And so if that's what the actual UI looks like, you can imagine how the data is all actually organized on the server. I imagine the Facebook database is incredibly, incredibly complex and incredibly large. And so having a way to identify what data you'd want from the Facebook database and then being able to display it in the actual UI, it would quickly become apparent that REST services, for the reasons that we mentioned earlier, just really wouldn't be sufficient. You'd have to create 1,000 different ways of representing a piece of data, and it would be a lot of coding on the part of your actual REST service team. So, GraphQL comes to the rescue. GraphQL is going to provide us an interface where we can actually specify what we want. We can specify what pieces of data we want related together, and then to give us back the actual structure that we're looking for, not giving us more data than what we need, but also not giving us less data than what we need. Okay? Now, GraphQL is purely about the interface to our server. GraphQL doesn't care anything about your business logic. It doesn't care anything about your data access. You can use it with any database. You can use it with any type of business logic that you want. The key is that GraphQL on the interface side is going to know how to access that information provided by your business logic and data access and how to relate it together to satisfy GraphQL queries. So it only needs to know enough information about how that data kind of fits together to know how to satisfy the queries that come through. Now, when you go to start working with GraphQL, you might think to yourself, okay, this sounds cool, but does that mean I'm going to have to go back and redo everything I've ever built in order to work with GraphQL? And the answer to that question is no. First of all, when you have an existing web application, you don't have to choose to do everything through REST services or choose to do everything through GraphQL. You can actually use a hybrid approach. So if you have a massive application, you already have lots of REST services. Those REST services are satisfying the data demands for what you already are doing. Then you can just simply implement new services as needed with GraphQL, and then gradually start to move your code over to using GraphQL to actually satisfy those data requests. Okay? Now, let's say you're ready to go ahead and start implementing some GraphQL stuff. Does that mean you have to go back and actually rewrite your actual service code to work with GraphQL? The answer to that is no. If you're creating brand new server-side services, then of course you can kind of code everything with GraphQL from the ground up and make sure it all works right and take that approach. But one of the things you can do with GraphQL is you can actually use it to wrap existing REST as well as other data services. And in fact, in our little demonstration application, instead of actually talking to, let's say, a local, server-side database, we're actually going to have our GraphQL services talking to a REST service to get its data and then use the whole GraphQL interface to put all that data together to be able to satisfy GraphQL queries. So you can basically introduce GraphQL into your ecosystem without actually having to redo everything from scratch. And for that reason, GraphQL is a really great technology. All right, it allows you to incorporate it as you want to make use of it. Now, GraphQL itself is a standard, not an implementation. A lot of times when we talk about things like Angular or React or what have you, those aren't really standards. Those are actual implemented code libraries, code frameworks. You have to actually go download them and then make use of them and build your stuff and everything else. But GraphQL isn't like that. GraphQL is a standard. And based upon that standard, there are many implementations that exist. In our code demonstration, we'll be using the JavaScript implementation with Node.js and Express. But you can actually implement your GraphQL in Java, C#, Ruby, Python, and there's a whole bunch of other languages. And you can actually go to graphql.org/code, and you can see the various languages that GraphQL has been implemented in. While you can, of course, do it in any language that you want to, you do have to keep in mind that it has to be a language that will actually work nicely for doing stuff on the web and things like that. If you try to go find some type of kind of off-the-wall language that doesn't have support for doing web-based stuff, it's not going to work out too well for you. But just kind of keep that in mind. But you can find the implementation of GraphQL in a lot of different languages. All right. When you start working with GraphQL, a lot of the GraphQL implementations come with a tool called Graphical. And we'll actually be making use of Graphical here in the class or in our webinar for doing our demonstration. And we can actually issue queries against a GraphQL server. It's actually quite a remarkable tool. It's one of the very many pleasant surprises that you encounter when you start working with GraphQL. The tool itself, out of the box, provides syntax validation. So when you're starting to work with GraphQL and you're struggling a little bit with the syntax, it'll help you out by validating that syntax before actually doing the queries and stuff. It does query beautification. So if you like to type in your code and it's a little messy, it'll actually go through and prettify it and make it look pretty so you can then save your query for later on, what have you. It does code completion. One of the things that's really nice about GraphQL is that it's got a really good introspection system for understanding the structure of your various elements that you're serving up. It understands the relationship between those elements, and it actually provides a really nice documentation feature. So it's actually really nice to get up and running with. With queries, you can actually enter the queries, you can specify variables, and then you can actually see the results of the graphical interface. You see the results of your GraphQL query in the graphical interface. Now, GraphQL is going to be running on the server side, as we mentioned. It's that replacement for the REST interface. And when you write your client-side code, you'll be accessing GraphQL via HTTP. So within a web browser, you can do this with standard AJAX calls. Now, it's important to realize that when you go to work with GraphQL, we're not following the actual REST service, REST verb, or HTTP verb, URI pattern, or anything like that. We're not going to be issuing like GET requests or doing a PUT request to do a replace. Everything's going to be via POST, and everything's going to be using the GraphQL query language. So GraphQL doesn't actually rely upon the details of HTTP to know what type of operation to perform. It just simply uses HTTP as a transport protocol for sending GraphQL queries back and forth over the wire. Now, what that means is that, A, you can use things like the XHR object, or you can use the Fetch API. You can also use standard REST service clients to actually make your queries. You won't be using all the verbs that you would typically use when doing REST services, but you can make use of all the REST service clients for actually typing in GraphQL queries and then executing them. Now, there are three different types of GraphQL requests. We have queries, mutations, and introspections. Queries will basically retrieve application data as a graph of nodes. And so you can kind of think of queries as like your GET requests. You're just going to go out and retrieve information and then make use of that information. There's another type of request called a mutation. And this actually allows you to change application data. In our little demonstration, we'll actually be inserting a book into our collection of book resources. And you can actually change application data through the mutation. Now, the mutation code, you can kind of write that however you'd like to. So you can update one node, you can update many nodes, you can really do whatever you want on the server side in terms of actually implementing the mutation. But the GraphQL mutation query is a special type of mutation query that allows a special type of query that allows you to pass data up to the server. Then finally, we have what are called introspection queries. And these are going to be the kind of queries that actually pull back the actual schema of the GraphQL server. So you can actually look at the various data structures and what their relationships are to each other. All right, so we're going to go ahead and get started here and take a look at some actual GraphQL queries and actually querying our GraphQL server. But before we do that, I have a couple of poll questions that I'd like to ask everybody and find out what everybody's level of experience is here with GraphQL and do a little bit of a review of the content that we just talked about. So I want to find out from everybody, have you used GraphQL before? And by before, I mean like before 20 minutes ago. All right, so we've got about 80% of the vote in here so far. And it looks like 92% of you have not used GraphQL. So cool, this will be a real treat for you to kind of see how this works. And then we have about 8% of the crowd who's actually made use of GraphQL before. That's awesome. Okay, so we'll go ahead and close that poll here real quick. And if you want to see the results here, there was the actual results from our poll there. And let's do another one of these real quick. So does GraphQL replace the REST interface? All right, so it looks like we got about 80% of the vote in here. And I'm going to go ahead and close the poll and show the results. Okay, so GraphQL actually does replace the REST interface. And I think some of you may have answered no because you might have been thinking, oh, okay, well, we can use GraphQL alongside our REST services and either wrap the REST services or still continue to use them. And all of that is true. But at the end of the day, the purpose of GraphQL is to change the way we actually interact with data. So instead of going through a REST interface, we actually go through GraphQL to interact with our data on the server. So in that way, it is actually a replacement for REST services. That being said, you don't have to get rid of all your REST services in order to make use of GraphQL. Through a number of methods and approaches, you can integrate GraphQL into your application over time. Is GraphQL a standard? This will be our last poll question for right now. All right, we got almost about 80% in. All right, cool. We got about 82% of the people voting. Let's go ahead and close that and share the results. Yes, GraphQL is in fact an actual standard. There are many implementations of it in different languages, but it itself is an actual standard. Perfect. So one of the things you'll run into, by the way, when you go to start working with GraphQL and you start looking for documentation, if you head over to the GraphQL site, you will actually find that it actually talks about it from the perspective of a standard. So when you see the code on the site, you'll see the code for the queries themselves, but you might wonder, like, where's all the code to talk to GraphQL via JavaScript or via Python or via Java? And you're not really going to find a whole lot of that. And that's because it really is a standard. So it actually talks about GraphQL from a standards perspective. If you wanted to actually figure out how to work with GraphQL via Java, JavaScript, whatever, you'd have to go find the actual implementations of GraphQL in those languages, and then go take a look at the websites that distribute those implementations and the actual documentation that comes with them. Okay, awesome. So with that said, let's go ahead and jump into our actual code thing here. We're going to be using Visual Studio Code as our editor, and we're actually going to be serving up all of our GraphQL stuff from Node. We're going to be using Express as our web server, and we're going to be using Webpack to be bundling and transpiling all of our code on the client side. For our REST services, we're going to be using something called the JSON server. If you ever need some quick REST services up and running really fast, you can check out the JSON server, and within literally 30 seconds, you have REST services up and running based upon some type of JSON file. So that'll be the tools and technologies we're making use of here as we walk through our little demonstration. All right, and let's come into here and get out of our PowerPoint slide. And let's take a look at some code here. Actually, let's go there. Okay, so here's our graphical interface. This is that graphical interface that I was mentioning to you earlier. All of this comes for free. You don't have to write the code for anything that you're actually seeing on the screen right now. You can actually, this actually comes free as part of the actual GraphQL library. So what we're going to do is we're going to come in here and actually write some actual graphical code here. And what we're going to do is we're going to type in query, and then we're going to say books. So we have our books, and then we're going to come into here, and we're going to say ID and title. Now everybody notice the actual code completion and IntelliSense that I'm actually getting here, okay? I'm actually getting the ID, I'm getting the title of the book here, and all of that's being provided to me as I'm actually typing in here to the actual query editor, okay? If we were to come over here to our documentation, you would see that we actually have documentation over here to the side showing us what we can query on. So for example, we can query on books, and I can click on book and you can see the actual structure of what our actual book stuff looks like. So now if we come over to here and we actually run our query, you're going to see that we get back an actual data set of books. Now, if we were to do this with REST services, so I'm going to copy my URL here, paste that in, say localhost 3010/books. If we would have done this with REST services, we get back all of our data. If we didn't want all of our data, we'd have to write a bunch of special code to actually support selecting which fields we wanted. But with GraphQL, we can actually come in here and be specific about which fields we're actually looking for. So if I want ID, title, maybe I'd like to have price. So I can come in here and say price, run my code, and now I'm getting my price data. Okay? Now, over here, you'll notice that we have an author ID. Now, depending upon how you implement your REST services, you could implement your REST services where you could provide additional information here inside of the actual query string to where you could say, go ahead and give me the author information in addition to the actual author ID. But once again, you would have to code all of that yourself, and I guarantee you that the way one organization would do it would be different from how another organization actually did it. Instead, what we can do with GraphQL is we can actually come in here and we can say author, and then we'll say first name, last name, and then we can run our query and we get our actual first and last name. Now, behind the scenes, which I'm going to show you in a moment, I actually had to write the code to link both of those node types together. Okay? GraphQL doesn't have some way of auto-sensing my data structures and knowing how to put them together. I actually do have to tell it, here's how you connect a book to an author on the server. But GraphQL provides me a standardized query interface to where I can actually come in here and say, not only give me the details of the book, but I also want you to connect in the actual author information. And this is what's known as a connection, actually connecting our book here to this author here. And if you want to think of the book itself as like a node, and think of the author as like as a node as well, we have an edge that we're basically forming between those two nodes and tying them together. This concept of an edge will be important for what we're going to talk about with Relay here in a moment or two. But here's an example of where I'm tying in my author data with my actual book information. So let's take a quick look here at the source code for how this is actually implemented. So here in my Visual Studio Code editor, I have my project opened up. And there's a lot of source code here, and we're not going to look at even a fraction of it. We just don't have time within our webinar. But when we have the class that's coming up, we'll be taking a look at it in the class, of course. So here we're going to come in and take a quick look at our query type. And I want to show you some code here that we have for our books. So take a look at books, and we also have a type here for book. Let me make that a little bit bigger. And if you take a look here, you're going to see that we have books, and then it's going to have some code that's actually going to go out to our REST service and fetch our book information. And this data here is going to be used to populate a list of book types. So what exactly is a book type? In GraphQL, you actually come in and define different types of objects. And you actually specify the fields on them, and you specify how those fields get resolved. So for example, down here for our author, it knew that our author, it knew how to resolve what an author is because I provided it a resolve function that says when you have an author ID and somebody actually requests the actual author data, here is where you go to get that author information. So GraphQL isn't instinctively or intuitively understand our data structures, but it makes it very easy for us to be able to connect together the different parts of our data and then expose that through this very convenient, easy-to-use interface. Now, the GraphQL query language is actually quite sophisticated. We're only looking at a small part of it here. For example, you can do something called a fragment. And fragments are very practical, but I'll show you an example of one. And we'll come in and we'll say fragment. And then we're going to set up a fragment for, let's say, book fields. So we'll say book fields on, and then we're going to specify the type. So we'll say on book. And then within our book fields, we can specify what book fields we'd like to pull in whenever we're using this particular fragment. So I'm going to say title, and then we'll say category. There we go. So there's my title and my category. And now I can take book fields here, and I can actually reuse this up here. There we go. I can now take that fragment, insert that into there. I can run this, and now take a look at the book fields. Now, the reason why this is important is because when you're actually writing your own client-side programming code, you can define fragments which define the shapes of things that you want to retrieve, put that code as like a hard-coded string or whatever in your application. Then when you make your GraphQL queries, you can reuse those fragments over and over again. And in fact, when we take a look at Relay here in a moment, you're going to see where Relay makes use of fragments all over the place to do the very thing that I just described. So that's another example of working with the actual query language. Another thing that you can do is we could actually query a particular book. So we could say ID, and then I could specify a particular book. Let's pull in, let's see here. We'll say book number 2. And so if I run book and then specify my ID, if you go back to your actual documentation over here, you'll see we have a book endpoint where we can pass in an ID value. If we run this code, looks like I don't have a book with a value of 2. Hold on real quick. Let's pull in all of our books again. And let's pull in our actual ID. It starts at number 4. So let's come into here and actually say book ID 4. And now I can pull in a particular book here. Of course, I don't have any, my category here, inspirational, doesn't match one of my enum types. So that's why you're getting the error there on category. So one of the things, for example, that GraphQL does, it supports something called enums. And if your enum values don't line up, you'll get really good errors like this when you're working with it. So it's a very, even though JavaScript, our implementation here is JavaScript, even though JavaScript is loosely typed, GraphQL is very strongly typed. So that's another nice thing about working with it. And let's see if we can pull in a non-inspirational book. There we go. Well, I got holes in my data set. So let's pull in book number 8. There we go. So now we have our book, and because mystery is part of the category enumeration, everything is good. And you can actually populate those enumerations, by the way, off of database values, which is really cool. Okay, so there's an example of doing a query for a particular book. The last one I wanted to do for you was an actual mutation to show you how you can actually mutate data. You'll see we have an actual insert book query here. And for the sake of time, since we got distracted by our error there, I'm just going to copy and paste the mutation in there for you. And so we can come in here and actually have a mutation query. And then when we have a mutation query, we have to specify some query variables. And we can actually set up some variables here. And for example, we're going to do an actual book titled new book. And what's cool is when you do a mutation, you not only specify what you want to insert, update, delete, whatever, but you actually specify what you want to retrieve back. How many times have you done an insert in something and all you wanted to get back was the ID value of the thing you inserted? You didn't want to get back all of the data, just the actual ID value. Well, here we can do that. We can specify what fields we want to pull back. So for example, if I just want to pull back the ID, I can run this and I'll get back just the ID of the new book that I inserted. If I actually wanted to get back the title, I could insert another new book. We'll call this one new book 2. Run this, and now you can see I get the ID and the title. So when you do your mutations, you not only specify the data that's needed to accomplish the mutation, you can specify the information that you want to get back. Now, the information that you get back is limited to whatever the GraphQL object type is for the return type of the mutation. For example, if we go into our mutation type here, you'll see for our insert book type, the actual, let's go here, yeah. For our actual mutation type here for insert book, you can see that our actual return value has to be the actual book itself. So you're limited to what your actual book type here is for your return value. You just can't insert a book and then say, only give me, rocking chairs or something like that. It has to be within the context of this book type, okay? And the last thing I'll run for you here real quick is an actual introspection query so you can see what that looks like, and then we're going to move on to Relay. So if you run this, you can see that we can actually query our GraphQL server for all of the various object types, and you can pull in all types of details off of your actual schema for GraphQL. That's actually how the documentation that you see in Graphical gets created. It just simply does an introspection query. And what's really nice about this is, for example, if you're working with enums, you could do an introspection query on the enum and get all of the enum values and then use that maybe in your client-side dropdown. And that's actually really nice to work with. So it's actually pretty cool what you can do here with GraphQL. Now, everything we've just said about GraphQL will literally work with any client-side technology you're working with. GraphQL itself has no requirement for using Relay or React or Angular or Backbone or jQuery or Ember or Polymer or Vue.js or any of those things. GraphQL is really just like REST services. It can be used by anything. You can even use Graphical if you're creating, let's say, maybe a C# desktop application or a Java desktop application. You're not limited to the particular technologies you work with. So that's GraphQL. And in the course, we're actually going to be going through a whole lot more details about how to actually build GraphQL servers and all the different types of queries that you can create and doing things like working with enums and stuff like that. So with all that said, let's go ahead and jump back over to our PowerPoint presentation here for Relay and talk about Relay here real quick. So what exactly is Relay? Relay is basically a framework for connecting a GraphQL server to client-side code. When you start working with GraphQL, you start realizing that you have a massive amount of data and you have a very complex data set. And so it's helpful to have a way of managing all of that information and keeping everything in sync on the client side. And that's where Relay comes in. So Relay is going to solve 3 problems for us. First of all, it's going to allow us to specify the data requirements for our views using declarative GraphQL queries. So when I show you the relay code here in a moment, I'm going to show you that in the relay code itself, in the actual JavaScript code that we're going to be writing on the client side, we're actually going to be determining what information our view needs and using the GraphQL query language to do that. What that means is we don't have to rely upon some intermediary store to know what information to give us, our view can just say, hey, I need these pieces of information, and then the actual Relay store knows how to fetch that from the GraphQL server. The second thing that's cool about Relay is it allows us to actually put those GraphQL queries with the views themselves. So instead of having to store things in all these different locations and then having to know where all of that stuff is, you can actually just co-locate them with the views. And then when you do that, it makes it easier to manage everything. It kind of follows the common pattern now of, for example, putting your unit tests with the actual unit that's being tested. So all that code kind of sits in the same place. Finally, one thing that Relay does for us is it's going to manage our mutations, or the actual changing of data. And the reason it's going to do that, it's going to be ensuring data consistency, what are known as optimistic updates, and error checking. So for example, when you start querying different parts of your graph, let's say I query a book and I ask for author data, and then I do a different query where I just query the author's endpoint and I get author data that way. I now have author data from two different queries. Well, the problem is, what if that data gets becomes inconsistent? What if I mutate the author? Relay is going to help manage that process of keeping everything consistent within our Relay store, which actually houses all of our data, and then feeding that data to our actual components based upon what those GraphQL queries say that they need. Also, it's going to support something called optimistic updates. I'm sure everybody in here has gone into Facebook, posted a reply to somebody's status, or liked something, and you notice that it instantly said you liked it or instantly said you posted your status update. But then if you looked at your friend's Facebook page, you saw that your status update or your comment or your post didn't show up yet. And that's because Facebook was doing something called an optimistic update. It accepted your input, assumed everything was going to work out, showed you what looked like a successful posting, while behind the scenes it was still doing its entire updating process and notifying all the other clients and everything else. Well, of course, if that update process fails, you have to have a way of undoing the optimistic update. Relay is going to help you do that. That comes baked into the entire Relay mechanism. And then finally, we have the error checking part of it. What's really cool is that if you code your Relay stuff incorrectly, let's say you write a GraphQL query inside your view that just doesn't make any sense based upon the actual GraphQL server, Relay has a way of error checking that. And so it'll actually grab the schema from the actual GraphQL server and check that against your client-side code, which is really awesome. And a little frustrating when you're not sure how to fix it. Okay, Relay itself is actually part implementation and part standard. In a sense, Relay is very much a standard. It has very specific ways that it expects your GraphQL server to be configured. But when we talk about Relay, we're also talking about a particular implementation. Because unlike GraphQL, which universally works across the board, you just have to implement it, Relay is still kind of locked into using React, and is still kind of locked into being used with JavaScript. So while you could certainly create other implementations, at the moment it's also partially an implementation as well. So from the standards perspective, Relay doesn't care which implementation of GraphQL you use. So for example, when I teach these classes, I use JavaScript for implementing GraphQL. But a lot of my clients that use GraphQL and Relay, they implement all their GraphQL services in Java. Okay, so Relay itself doesn't care what your server-side implementation is. What it does care about is that the actual structure that's exposed by GraphQL matches the structure that it's expecting. Also, technically, GraphQL doesn't actually care what component library you use. As long as, from a conceptual standpoint, you can interact with the Relay store and you can use GraphQL to configure the data that your views need, Relay is okay with that. So in principle, Relay doesn't really require React. However, in practice, React is basically required. And that's because Facebook's implementation of Relay doesn't really work with anything else. It really only works with React. And so right now, for all the places that I've encountered that are using Relay and GraphQL together, they're all using React components. So you're definitely going to be walking into what I call the Facebook stack. React, GraphQL, Relay, a lot of those places also use Jest for their unit testing. They use Flow for their static type checking. They kind of use the whole Facebook stack of technologies. Now that being said, if you actually go out and Google around for Relay and Angular 2 or Relay and other UI frameworks, you will actually find people who are actually trying to implement Relay with those other frameworks. So they're trying to take the basic idea or the standards part of Relay and actually make it with other libraries, because at the end of the day, the same problems that Relay solves for React would be the same problems that even Angular 2 would have when trying to talk to a GraphQL server. So when we're doing our code review, we're actually going to be looking at Facebook's implementation of Relay, which does in fact use React, and all of our client-side code, of course, will be using React as well. So let's talk a little bit about the Relay GraphQL standard. This is actually quite important, especially since you'll be implementing your own GraphQL servers. So basically, Relay expects your GraphQL server to have basically 4 different structures. One is there has to be a single root node. So in our GraphQL implementation, we had multiple root nodes. We had a root node for books, a root node for authors. In Relay, all of those top-level nodes would actually be placed under one additional single top-level node. Sometimes people will call that the viewer node, what have you. And so you'll basically put all of your stuff under that one top-level node, and then Relay will operate off of that one top-level node. Second, every node in the graph has to have a unique ID. And what that means is that Relay wants to have the ability to be able to query for any node in the system with a single ID. Now, this is a little bit harder than you might think, because take, for example, authors and books. Within the set of books, each book has its own unique ID. Within the set of authors, each author has its own unique ID. But an author could have an ID of 4, and a book could have an ID of 4, and so that ID of 4 is not globally unique. So what you have to implement on the server side is basically a globally unique ID system. And the way this is typically done is to actually take the type name and take the actual ID of the book or the author and put the two of those together and then do some type of like base 64 encoding of it and generate a unique ID that way. And the reason why it's base 64 encoded is so that you can decode it and then ultimately extract out that type and that unique ID to actually query the database for that information. In terms of the third thing is you have to have a defined connection, particularly for supporting paging through your nodes. But Relay actually requires a little bit more sophisticated connection between, for example, let's say a book and the author. And the reason for that is that Relay, in addition to being able to connect 2 different types of nodes together, also is interested in having metadata about those connections. That's actually one of the more powerful things when it comes to working with graphs, right? So, for example, I have a collection of books at my house. So if you were to think of me, the owner, and then a bunch of books, you'd think, okay, the owner just has an array of books. But what's really interesting is when you start doing GraphQL coding and thinking in terms of graphs, the actual edge, the actual connection between me and the books actually has relevant information as well. For example, there might be one book that I read more often than I read other books. And so that actual edge would have its own special value, indicating that that particular edge is of greater value to me than maybe another edge would be. And so Relay supports all of that kinds of stuff in terms of its actual structure. Finally, there's a standard structure for working with mutations, and this is actually one of the more difficult parts of working with Relay, is working with this standard structure. Basically, Relay needs to understand how does a mutation affect the overall graph. And it has to know that so that it can do its whole data consistency mechanism. So that when I update one part of the graph with information, it knows how to update things throughout the graph with whatever those changes are. And so it has to have knowledge of that. And unfortunately, Relay can't intuitively look at all your stuff and know how to do that. You actually have to tell it what things care about what other things, and then it will take that information and then keep everything consistent. All right. Now, in our actual implementation, we're going to be doing everything with JavaScript and Node. I'm going to be using the GraphQL-Relay package, and that's actually going to provide me the library code to create all of these structures that we've been talking about. You can create them yourself from scratch if you want, and I've actually done that before, and it's a fair amount of work. It's actually easier to use the GraphQL Relay library, so I recommend you take that approach. But you want to look for these types of libraries that would exist in your other implementations so that you don't have to code all these things completely from scratch. For the React side of things, because like I said, Relay is a framework, so it's actually going to have a part of the server it's going to be involved with, but also a part of the client side. And we're going to be using React Relay, which is going to provide us various containers and other things to work with our routes and mutations for actually working with the Relay store and updating our UI. So let's go ahead and do a quick little exploration of Relay. I'll walk you through a few things, and then we'll take some questions. Technically, the webinar ends at noon, but I don't have to go anywhere at noon, so we'll take as many questions as people have past noon, and then, of course, if you have to take off, not a problem. You can go back and listen to the recording later. Okay, so coming over to here now, let's actually head over to our application. So I've got a very simple looking application here, and actually before we do that, I need to make one little change on our server side here. So in my server here, I have it set up at the moment to only be serving up a GraphQL server. But I need to actually turn on our Relay enabled GraphQL server that will actually have all the structures that are needed for Relay to be able to talk to the server itself. So I'll make that change. I'm going to fire this up. And what you're going to notice as this is processing is there's a whole lot of work going on here. One of the challenging parts about working with Relay is actually getting all of this configuration up and running. When I was first putting this together back when I was first learning Relay in the beginning, I actually had to spend a fair amount of time going through GitHub issues and stuff like that to figure out how all this works. And that's because the Relay documentation is much better now, but it didn't used to always be all that great. And so when you go to pull down these project files later on, take a good close look at the configuration. That's actually one of the more challenging parts of putting all this together. But let's head over now to our application, and we're going to reload our page here. And so you can see we have our, there we go. Okay, now we can see our actual titles there. So I've got a little table of books here, and we have the ability to edit and delete as well as create a new book. And you can see down here we can change our page length, and when I change it, it changes the actual length of the page. We can go to the next page, we can go to the previous page, stuff like that. You can also see down here where these various numbers and stuff are being updated. So for example, if we went to the last page here, we could, actually let's do this, let's go back to one of these previous. Let's take this historical one here. We'll just come in here and delete this. And you can see now our book was deleted and all of our information here got updated. To make all of that happen, to actually do the mutation, do the delete, navigate the pages, all of that stuff was actually being controlled by Relay. Relay was taking the updated information about what page we wanted to look at. Relay actually conducted the mutation. When the mutation was done, Relay grabbed all the information to update the UI here for us. So let's go ahead and take a look at that code here a little bit. Now I'm going to warn you, this is a ton of code. We're only going to look at a very small section of it to kind of give you a flavor of what you're working with. Relay is not something where you can just code 1 or 2 lines and see hello world. It has a lot of moving parts, and you basically have to get all the little moving parts in place. And then once you do all of that, then you can finally turn the light switch on. And so we're just going to look at a few small pieces here so you get an idea of what's involved for making this happen. So coming back over here to our source code, we're going to look at this purely from the client side, not from the server side. So if you come into here, we're going to have our actual application, and you're going to see here that we have our React DOM render. So if you're not familiar with React, some of this stuff may look a little bit confusing to you, but if you know React, it should be relatively straightforward. You're going to see that Relay has something here called the Relay root container. When you work with Relay, it implements the pattern of a container versus a presentational component. So if you've ever used Redux before, you might be familiar with that concept. The idea of a presentational component is it just simply receives information and displays it. A container component, on the other hand, doesn't focus so much on displaying stuff as it focuses in on how do I get my data, where do I get it from, how do I feed it into my presentational component. Well, Relay, because it's focused on connecting to that GraphQL server, maintaining a local data store, and then updating the UI, it basically serves as this container component that's going to allow us to connect our presentational components into Relay itself so that they can actually get their data. So coming into our code here, you're going to see we're going to have our book tool component. Actually, let's go to a book tool container here. You're going to see that we're going to create this container by taking our book tool presentational component and basically wrapping it in this container that has a bunch of information that's going to define stuff about our Relay store. For example, we're going to have some variables that we're going to initialize for what page we're on, what's the default page size, where are we in the cursor of books. So for example, when you work with a collection of data and you have a bunch of connections, it uses a cursor approach to knowing, am I on the first page, the last page, which part of that connection list am I actually looking at and working with. Down in here with our fragments, you're going to see where we're actually defining what type of data we want to be pulling into our actual container here. So you can see that we're telling it to pull in our viewer, which is our top level root node, and then we're getting the ID, and then we're specifying the books and stuff that we want. All right, so we have all of our cursor information. So for example, the first, the last, after. And then we're going to be pulling in our total count of books. We're pulling in our edges. And then inside of here, we have our node where we're actually pulling in the actual properties or fields that we want to pull in off of our book. Also down here, we're defining our various mutations for how we want to interact with our book data. So for example, we did our delete book from earlier. Now, if we come into the actual book tool here, you'll see that book tool has a lot of the same functionality that you would typically find in a React component that was serving as like a container component. For example, we can append the book, update books. We have the actual append and update wrapped up in a single save book method. We have the ability to turn on the actual row that we want to edit the book of, the delete book. You'll notice that Relay Store provides us a commit update function. So we have commit update there, commit update. And what we pass into it is the actual mutation object that we want to perform. So the Relay Store doesn't know anything about inserting or updating. It just knows about mutations. And then we define our mutation object. We define our input types for the data that the mutation requires. And then we tell the Relay Store to go do that mutation. So because the Relay Store doesn't understand so much about deleting or things like that intuitively, we actually have to configure these mutations to instruct the Relay Store what to do. So if you come into our delete mutation here, you're going to see we have a bunch of different pieces of information. For example, we have a fragment, so our delete's going to be occurring under this viewer top-level node. The mutation is going to be the delete book. This is similar to the insert book that we looked at during the GraphQL demonstration. We're also going to have a get variable, so we need the actual book ID that we want to be doing our delete on. Now this is kind of interesting here. This is going to allow us to tell Relay what type of graph operation we're performing. So don't think of this in terms of deleting a book, but think about it in terms of when you delete a book, what does that look like in a graph structure? What type of operation are we doing on the graph? And that's what we're defining here. So we're going to be doing like a node delete operation here on the graph itself. And then we have to specify various pieces of information so that it understands what parts of GraphQL are being affected. The last thing I want to show you here is what's called the FAT query. What the FAT query does is it tells Relay, once I do this mutation, what pieces of information do I have to update as a result of the mutation? So Relay doesn't know that automatically. We have to be very explicit about that. Putting all of this together is difficult to do. It looks very easy here with it already being coded, but I promise you, writing this code the very first time I ever did it was really hard. And so when you start working with Relay, if you feel like it's really frustrating and really hard to do, that's because it is. However, once you figure it out, once you get all the pieces put together, it's really awesome. So one of the things we'll be doing in class is actually putting all of these pieces together. Okay? Now, the last thing I want to show you is the actual operations that we're doing here for changing the actual switching from page to page, that kind of thing. Down here, you'll see where we have some buttons, for example, for doing the previous page and the next page. And then we have some information about what page we're on, that kind of thing. And what you're going to see here is that we're actually referencing the viewer off of our props. So when you work with Relay, it's actually going to be passing in your data from the Relay store, passing it in as props into your component, and then you work with it the same way that you would work with any props in any type of React application. So your presentational component doesn't have to know all the details of Relay necessarily. It can just work with props. There are some variables which are maintained inside of Relay. For example, I showed you how we initialized what page we were on or the book page size. For those types of things, you actually can access them directly off the Relay store, which is passed into that top level component. But if you actually come into our edit row component, you're not going to find anything really about Relay inside of here at all. This is a true presentational component, simply receiving all of its information from a higher level component, and it doesn't have to know about Relay. So when you do code your React application, you're following the same best practices in terms of having your container component versus your actual presentational components. Okay, cool. So with all that said, the last thing I'd like to mention here before we continue on is that if you go to the actual Wintellect website and you go down to training, under public schedule, you're going to see a bunch of training classes that Wintellect offers. All of them are awesome. You should take them all. But for the class that's particular to this content, if you come down here, on Wednesday, March 29th, we're going to be going into a lot greater detail on GraphQL and Relay. And at the end of the class, you will have actually built an application that uses both of those technologies. So if you want to go into greater detail for all the stuff that we've covered here in the webinar, check out the class here on the Wintellect website. And to wrap things up, here's some information about Wintellect itself. Wintellect is a top-notch consulting and training company. I've worked with these folks for years, and I can tell you they're some of the best in the business. So if you need help with project consulting, or you're looking for training, whether it's actual on-site customized training, online training through public classes, or even these webinars, you definitely want to come to Wintellect. They can help you out with all of that stuff. Particularly, their people are especially specialized with Microsoft technology. So if you're using a lot of Microsoft stuff, these are the people you want to talk to. But they also do a tremendous amount of stuff in the web space, in the open source space, and can't recommend them enough. They do an excellent job. So at this point, I'd like to go ahead and wrap up the webinar. Be happy to take any questions that people have. You can actually post them into the webinar itself, and then I can see the questions, and then I'll go ahead and go through them and answer them. We can keep going, so I'm going to keep answering questions until I run out. We don't have to stop at a particular time. On the slide here, you're going to see the actual GitHub URL for the source code, and you have my email address as well. And in fact, what we're going to do is we're going to take this thing right here, and I'm going to copy that. I'm going to expand out the chat window, and I'm going to go ahead and send this link out to everybody in the chat window if you want to be able to go check out the GitHub repo. All of the code is already up there and working, so there's nothing to post up there from the webinar. And you can check all that out on your own time. If you have any questions about any of the code, don't hesitate to send me an email message. I'm more than happy to answer. So let's take a look at some of these questions. So the first one is, what GraphQL, I guess, library would I recommend for C#? I have not implemented any GraphQL servers in C#. I've done a lot of C# coding in the course of my career, but most of my focus is now more on Node. So I know if you Google around, you'll find, I don't believe there's that many C# libraries to choose from. If I was going to pick any library from any language, I would look for the one that was being updated the most and had the most community support. A good way to judge that is take a look at how many actual issues are being supported, are being submitted by people. No piece of software is perfect, and if you find a library that has no issues being submitted, no one's probably using it. But if you see a lot of issues being submitted, a lot of pull requests, a lot of activity, and it implements the actual GraphQL standards the way you'd expect them to be implemented, stuff like that, that would be the library that I would go with. And that's true for any language. Source code for the demos, you can get that from the actual link that I just posted into the chat window. And everyone who attended the webinar will also get a follow-up email where you can go watch it again, and the link and stuff is in the slide deck. Okay. Relay and Apollo client and when to choose each. I am not familiar with the Apollo client. I'm going to have to check that one out. So I don't actually have an answer for you on that one. I am so sorry. One of the awesome things about doing teaching for a living is that I'm always running into folks who find new technologies that I haven't heard of. And every time I think I've heard of every technology out there, there's some new one that I haven't heard of and it pops up. So thank you for mentioning the Apollo client. If anybody wants to go check it out, I'm going to go check it out, and we can see what it does for us. Let's see. Okay, Babel. So first of all, whenever I do React stuff, I always use JSX. So I'm always going to be using the Babel transpiler to transpile my JSX. I also like to use the latest and greatest JavaScript stuff. And while most modern web browsers support ES 2015, there are features from ES 2016 and 2017 I like to make use of. And so there's also some other features which aren't even JavaScript that Babel will support as well, like property declaration, stuff like that. So I like to use Babel across the board whenever doing any JavaScript development now. In terms of Relay, you have to use Babel because there's something called the Babel Relay plugin. And that plugin actually does the validation. It actually goes out and pulls down your GraphQL schema and then does a schema comparison between the actual schema and then your actual Relay GraphQL queries. And so it makes sure that everything lines up. So you do have to use Babel when doing Relay to do the validation process. So we also have, should GraphQL directly talk to the database or could it be linked to? So GraphQL doesn't really talk to anything directly. It just talks to whatever APIs you've created for supplying the data. So you can use a REST API to supply the data. You can write code that talks to a database and then supplies the data from the database. GraphQL will work with any of that. In terms of actually writing actual database code, like inside of the resolve function that I showed you, I don't really recommend that. I'd write my actual database code inside of some kind of other library and then reference that library from GraphQL. You want to make sure you have a good separation of concerns. There's no need to tightly couple the GraphQL interface to your specific SQL statements that you're writing, and instead implement those in two separate classes and then connect the two of them together. Okay, so we had a question here about OData. So this is a common one that I get when I teach at places that make use of a lot of Microsoft stuff. GraphQL and OData are kind of similar in a way. They do kind of the same types of operations. I tend to prefer GraphQL. I think GraphQL has a little bit wider support in terms of being, I know OData is an official standard. I know that you can implement it in a lot of different places, but I've found that OData tends to be a little bit more Microsoft-centric. So if you're working with other technologies that aren't quite as Microsoft-centric, GraphQL is a good option. Also, too, because Facebook probably has the most complex website ever in terms of working with graphs of data. GraphQL is very well designed for that. And so it's probably a good solution to use for the stuff that you're working on as well. Let's see here. Appropriate write schema. Sure, you can put your You can put your schema into a file, and then you can actually write code that will read that schema and then generate the necessary objects for your platform. Or you can take your schema, generate a file from your actual live service, generate a schema file from it, and then use that file over and over again for doing your relay validation. It all depends upon what you're doing. For example, I copied and pasted some GraphQL queries directly into the editor. If I was coding an application, I'd probably make those as hard-coded strings, similar to what you might do for a SQL statement. So how you actually handle your GraphQL and your schema just depends upon what it is you're trying to do in your particular application. All right, let's see here. FileCore library from Netflix. I have not used the FileCore library from Netflix. If I had to guess, and I could be completely wrong here, what you're probably getting at is that Netflix, when they implemented their REST services or something similar to them, probably implemented a customized query language that allows you to interact with their stuff in a way to which you could actually query the data that you wanted. So the question would be, if that's what FileCore does, it gives you a more customizable query interface, how would that relate to GraphQL? They would basically be the same thing, except that FileCore would be specific to Netflix. Now, if Netflix took FileCore and made it a universal standard, then they would kind of compete against each other. And so at that point, it would just depend upon which one had a greater acceptance. Because React is so massive in terms of people, everyone uses React to build web applications, and because of the high profile that things like Redux gets, I have a feeling that using GraphQL from Facebook would probably have a little bit larger following than maybe using a library from Netflix. But once again, you just have to see what the actual user base for that would be. I wouldn't want to make an argument, saying one was better than the other, because like I said, I don't know anything about FileCore and I haven't used it before. The reason why I focus so much on the GraphQL side is because I do a lot of React training, and a lot of places that use React are interested in using GraphQL because it is part of that Facebook stack of technologies. Okay, so that was actually the last question. Does anybody have any other questions they'd like to ask about anything that we've covered here in the webinar? Any other related technologies? Relay, React itself, JavaScript in general? Okay, so the question was, my books and author appears to be normalized. Yeah, so I'm not actually running a SQL database. I, however, do have a very simple JSON file, which, you could basically think of it as like a books table and then an authors table and then a relationship between them. So the question is, how does all that work with NoSQL? So really, when you think about most NoSQL data sources, let's take MongoDB. That's really a document storage platform. So you kind of think of a whole document being stored, and then that document can be more than just a simple table structure. It's really a tree structure, and it can have a lot of different data hanging off of that tree. So how does that factor into GraphQL? Simply, all you'd have to do is write your MongoDB queries to supply the data in a way that would make sense for resolving one of those GraphQL nodes. So for example, if I had an example of a document that had a book and then inside of it it had the author, I could actually set it up so that when I query the book information from Mongo, I could set up a little cache where I had book information and then I had author information, and then my GraphQL would just resolve that information from the cache instead of actually contacting Mongo or something like that to get the information. It would just all be about how you wanted to code that. So GraphQL doesn't tell you where to get your information from or how to even make it convenient for GraphQL to access it. You have to make all those decisions. What GraphQL is going to allow you to do is easily work with its query language, and then you just simply have to tell the nodes where to get the information that they need. Okay, is there a query QL on the Angular 2 stack? So can you use GraphQL with Angular 2? Absolutely. So Angular 2's HTTP service in terms of its helper methods, is primarily geared towards working with REST services. It implements all the common HTTP verbs as actual helper methods. If you were to use GraphQL with Angular 2, you would simply just use the post helper method. You'd actually have to construct all of your actual queries and data and everything and then make the request. But in terms of the actual response that you would get back, Angular 2 would have no problem handling the JSON that comes back and then allowing you to work with it. There wouldn't be anything really extra special that you'd have to do to make that happen. If you wanted to make it work with Relay, that'd be a different story. If you decided to make Angular 2 work with Relay, you can Google around for that. You'll actually find some articles where some folks are working with that to try to make that happen. But that would be a lot of work, and that would not be something that would be standard or working straight out of the box. You'd have to do a lot of work to actually make that happen. Using Relay with React, that'll work out of the box because Facebook provides the actual library code or framework code to do that. All right, data loader inside the GraphQL server. If the person who asked that question would like to describe to me what you mean by data loader, I want to make sure that we're both thinking about the same data loader when you ask that. But I'll hang around for a second or so if you want to go ahead and post up a second question talking about the data loader that you're referring to. All right, we'll give you another second or so. Do we have any other questions in the class? Any other questions about anything related to any of these topics? Okay, so for the data loader, I'm not 100% sure what you're getting at. If you're talking about some type of implementation of some type of caching mechanism on the server, in terms of caching your data and then having GraphQL, when you do your resolve function, actually interact with that cache. If there's a data loader library out there that you're referring to, I'm sorry, I'm not thinking of it off the top of my head, but you could certainly absolutely make use of a third-party library that took care of that caching for you, or you could actually implement your own way. The key with the GraphQL stuff is understanding that the resolve function just goes to wherever it is you want it to go to get the information that you need to actually satisfy that query. Okay? All right. If you have additional questions about that, just follow up with an email to me afterwards. And if there's something specific that you're referring to that I'm just not thinking of at the moment, be more than happy to continue to answer that question after the webinar is over. Okay, so let's see here. Do we have any other questions? As they're coming in here. Okay, so we have a question about a C# app requesting data. The C# application would just need to make an actual HTTP request up to the GraphQL server to make that, to pull in that data. So whatever library you're using to do that, to actually make those HTTP requests, you just simply put in your query and then you would get back the information you were looking for. All right, let's see here. Okay, so in terms of, we have a couple of questions here about some of the implementation details with certain languages. With GraphQL, GraphQL itself is strongly typed in the sense that you have to define your schema and the parts of it, and they all have to actually have specific types, you know, whether it be an object type or some type of primitive. In terms of the implementation details of either consuming the results or actually implementing the server, you are bound by all the requirements that your language requires. So for example, if I wanted to pull down JSON data of books into my C# client, and then take that data and then make it available in terms of actual book objects in C#, I'd have to actually create a book class to do that, or do some type of dynamic language runtime programming, what have you. GraphQL is not going to do any of that for me. I'm going to have to actually define my data structures, both on the client side and server side. GraphQL is really just providing that query interface to allow me to easily query that information. Okay, GraphQL versus dynamic link. GraphQL is really just a query language for making queries over HTTP in a very cross-platform way. Dynamic link would be just limited to, working in a .NET environment and making your requests for data in that way. Okay, very good. Well, I appreciate everybody taking time out of their day to join us for the webinar. Take a look at the class if you're interested in learning more and building an application with GraphQL and Relay. And if you have any other training needs, don't hesitate to contact Wintellect. I know they'd be more than happy to help you out with that. And if you have any questions, you have my email address. I will actually post that as well in the chat window so everybody can get access to that too. Don't hesitate to email me if you have any questions. I'm always happy to help out over email as much as I can. And I want to thank everybody for attending, and we'll go ahead and end the webinar now. Thank you for coming out.